Hello, welcome to the EPG Pathshala program in Linguistics. I am Pramod Pandey, Professor, Center for Linguistics, Jawaharlal Nehru University, New Delhi. I am the principal investigator of this project. I am also the coordinator of the paper from which we are going to listen to a discussion of one of the modules. The title of the course is Advanced Phonology, and the title of the module is Doing OT 2. Listen to the discussion.
Doing OT Part 2. In the previous module, we saw that OT analysis requires a careful selection of the problem, a good descriptive generalization of the data which leads to the constraints that follow, how to select the relevant constraints. OT does not provide an exhaustive list of constraints. We have to theorize and posit constraints based on the universality of con and OT principles. And finally, we saw an example of the original table in our attempt to rank the constraints. In this module, we will see the different types of tables and their different roles in analyzing data. We will understand how to check our constraint rankings and whether our ad hoc constraints suit our needs as is or do they need some modification. And finally, we will conclude with a brief description of computational methods of doing OT and the areas where they could be most useful. Amongst the different kinds of tables, the first is the original violation table. As you can see in one of the columns, C3, row 1, is shaded. This shaded cell indicates that the performance of the output O1 on the constraint is irrelevant to the outcome as the decision has already been made by the higher ranking constraints C1 and C2. Prince in 2002 introduced a comparative table which focused on favoring relations. For each losing candidate in the table, we see if a constraint favors the winner over this loser, or favors this loser over the winner, or favors neither. You can see the example in the table 2. Since C1 dominates C2, the winner favoring W takes precedence over the loser favoring L. Because every loser row, in this case O2 and O3 row, because every loser row has a W and that W is to the left of every L, that is, the W dominates L, this table shows that the winner O1 beats the losers O2 and O3 with these constraints as they are ranked. One of the drawbacks is that with examples of even moderate complexity, it can be difficult to fill in the W's and L's of a comparative table without first constructing a violation table. The solution to this problem was the use of the combination table, which includes information about violations as well as the W and L notations of the comparative table. First, construct a violation table like in 1 and then add the W and L annotations to the loser rows. This is an ideal instrument for constructing and presenting ranking arguments. It basically guarantees that the first two requirements of a valid ranking argument are met, that is, constraint conflict and a winner. The third condition on valid ranking arguments says that we can legitimately conclude that C1 must dominate C2 only if there is no third constraint C3 that could be doing the same work as C1. There is a dichotomy between ranking arguments versus selection arguments. The ranking problem states that the winner is known, but we have to figure out the ranking to account for the data. The selection problem, on the other hand, states that the ranking is known but not the winner. This situation arises when we are trying to determine what our analysis predicts about additional data that weren't available when the analysis was first constructed. The comparative or the combination format is best for the ranking problem, whereas the violation format is best for the selection problem. However, there are some limitations to ranking arguments. First is that unviolated constraints are unrankable. They always agree about the choice of the winner since every winner obeys both of them. Without conflict, there can be no ranking. McCarthy identified that the unviolated constraints is a useful method of narrowing down the set of potentially problematic candidates. The second problem with ranking arguments is the stringency relation. Stringency is the relation between constraints with respect to the violations they make. That is, C1 prohibits more constructions than C2, thus it is more stringent than C2. An example of constraints in a stringency relation is given in 5. The onset consonants that are unfaithful to voicing are a proper subset of all consonants that are unfaithful to voicing. Identical voice, the constraint called identical voice, is therefore the more general and hence the more stringent of these two constraints. Constraints in a stringency relation never conflict with one another. Since every violation of the specific constraint is also a violation of the general constraint, conflict is not possible. The third limitation is the tiebreakers. A losing candidate ties with the winner on all the constraints that have been used so far. We introduce a constraint that chooses the winner over the loser, but the problem arises when we have to rank this constraint. Should it be ranked higher or lower? One must keep in mind that these tiebreaker constraints are unrankable. Their sole purpose is to break the tie and help the optimal candidate surface. These constraints are free ranking. Apart from these three limitations, two more situations can arise where ranking is difficult. First, there are pairs of constraints that never conflict because they deal with completely unrelated properties of language. And second, sometimes constraints may remain unranked out of ignorance. We can imagine how the constraints would conflict, but we can find no pertinent data in the language under analysis. To check the ranking argument, McCarthy proposed a few steps at the end of an analysis. For example, check for other ways of an output becoming less marked. Double check with the rankings where max is crucially dominated. And finally, there are at least one or more than one fully faithful candidate in the set because of possible structural differences like syllabification. The fully faithful candidate obeys every single faithfulness constraint. So it is crucial that it be ruled out for markedness reasons if it isn't optimal. And lastly, let us look at how to do OT with software. If you have a simple linguistic system and up to 8 constraints, you can rank the constraints simply by creating a comparative table. However, it's virtually impossible to do a factorial typology with a large set of constraints, and thus OT software becomes helpful. There are two softwares available. One is OT Soft, proposed by Hayes and colleagues. This is the first tool for ranking constraints and doing factorial typology. It also provides tools for different kinds of ranking assumptions and how to structure the display of ranking arguments. However, it is limited to PC computers. The other software is called OT Workplace, proposed by Prince and colleagues. This is an add-on to Excel and is also limited to PC computers. A very useful feature of this OT environment is that it displays full comparative table even when there is no possible ranking of constraints. This enables problem solving because you can see visually the ranking requirements that need to be resolved, and it leads new hypotheses about what the constraints are and how to classify your data with hidden structure. In summary, in this module, we saw different kinds of tables and their uses. We understood the limitations of ranking argument. Finally, we checked the constraint rankings and arguments for any discrepancies in the ranking argument. And finally, we looked at two OT softwares which are available for linguistic analysis.
Summary. As you would have noticed, this module is a continuation of the previous module, doing OT1. The focus in this module has been on the kinds of tableau used in OT analysis, the limitations of ranking arguments and how to go about them, how the constraint rankings can be checked and either discarded or kept. The author concluded with a short introduction to computer software that helps in carrying out OT analysis. Go through this module carefully and try and do as many of the exercises as possible, and look up the references on the website as well as in the bibliography. Thank you.